In this tutorial, we will determine the intervals where a given function is increasing. Determine the intervals where the function f of x equals x squared times 2 to the x is increasing. So remember, when you see increasing or decreasing, you should think of the first derivative. The first step for us is to set f prime of x equal to 0 and solve for x. Then we will make a sign chart. So I'll rewrite the function f of x equals x squared times 2 to the x. To take the derivative, we need to use the product rule. X squared will be a, 2 to the x will be b. Then the derivative, f prime of x, is given by the formula a prime b plus ab prime. So I'll just go off to the side and compute a prime and b prime. If a is x squared, then a prime is 2 times x. And if b is 2 to the x, that's an exponential function, then b prime is 2 to the x times ln 2 times the derivative of the exponent, which is 1. So again, I'll just emphasize what a prime, b, and b prime are. Now I need to set this derivative equal to 0 and solve for x. So to solve for x, I'm going to extract common factors in the two terms. I have 2 to the x in the first term and the second term, so I could pull that out. And I have an x in both terms. So in the first term, I'm left with 2. And in the next term, second term, I'm left with x ln 2. So I have a product of 3 factors that equal 0. So I can look at them individually. At least one of these is going to equal 0. 2 to the x can never equal 0, of course, because an exponential function never crosses the x-axis. The second factor equals 0 when x equals 0. And the third factor, 2 plus x ln 2, equals 0 when x equals negative 2 divided by ln 2. So I'll throw both of these values on a number line. So negative 2 divided by ln 2 will go on the left of 0 on the number line since it's a negative number. And negative 2 divided by ln 2 is approximately equal to negative 2.89. So I'll have 3 intervals. The first goes from negative infinity to negative 2 all over ln 2. The next one goes from negative 2 over ln 2 to 0. And the third interval goes from 0 to positive infinity. So there's the first derivative, and underneath f of x. So we'll pick a number that lies in the first interval and plug it into the derivative to obtain the sign of the answer. Remember, if the sign of the answer is positive, then our function is increasing, and in this case it is. So now I'll pick a number in the second interval, like negative 0.1 for example. That will give me a negative answer, which means the graph of the original function is decreasing. Now again, picking a number in the third interval, I'll get a positive answer, which means the graph is increasing on that interval. Therefore, f of x is increasing on the interval negative infinity to negative 2 over ln2 and 0 to positive infinity. And this completes the exercise.